Welcome to a lesson on conditional statements. In this video we'll cover if-then statements and their converses, as well as if and only if statements. If it is raining, then it is cloudy. If LeBron is on the team, then we will win. If x equals 3, then x squared equals 9. Here are three examples of if-then statements. So in general, if P, then Q is an if-then statement, where P is called the hypothesis or antecedent, and Q is called the conclusion or consequent. Here's another notation used for if P, then Q. And an if-then statement is called a conditional statement. Now, conditional statements can also take on a variety of forms. It doesn't always have to be in the form of if P, then Q, as we see here from the previous screen. So if x equals 2, then x plus 5 equals 7 could be expressed in the form of P implies Q, or x equals 2 implies x plus 5 equals 7, or P only if Q, where x equals 2 only if x plus 5 equals 7, and we can also say P if Q, meaning x plus 5 equals 7 if x equals 2. Conditionals can sometimes also be expressed without the words if and then, but can always be restated using if and then. Let's practice writing these conditionals as if-then statements. The sum of two odd integers is even. This can be expressed as if the sum is two odd integers, then the sum is even. The second conditional, I'll go for a run if the weather is nice, could be expressed as if the weather is nice, then I'll go for a run. So it is important to read this carefully and identify which part is the hypothesis and which is the conclusion. It's not always in the order that's given. And for the third statement, I'll quit my job when I win the lottery, could be expressed as if I win the lottery, then I'll quit my job. It could not be expressed as I'll quit my job, then I'll win the lottery. That would not mean the same thing. An if-then statement can be true or false. It is false if just one example can be found for which the hypothesis is true and the conclusion is false. And the example given to make an if-then statement false is called the counterexample. So if we have the conditional if a triangle is isosceles, then it is acute, if we can find one isosceles triangle that's not acute, it would make this if-then statement false. So is it possible to sketch an isosceles triangle that is not acute, meaning one of the angles is obtuse or between 90 and 180 degrees? And it is possible. Here's an example. If these two sides are of equal length, this angle is obtuse, and therefore this is an example of an isosceles triangle that is not acute. And therefore this is the counterexample of the given conditional statement. The next conditional statement is if x squared is greater than 9, then x is greater than 3. When we first look at this, it may seem true, but let's see if we can determine a counterexample. If x squared equals 16, and 16 is greater than 9, x equals negative 4 is a solution. Because if we sub in negative 4 and square it, a negative times a negative would be positive to give us 16, and negative 4 is not greater than 3. Therefore, this proves the conditional statement false. Now let's talk about the converse of an if-then statement. When the hypothesis and conclusion of an if-then statement are interchanged, the new statement is called the converse of the original if-then statement. So the original statement is if P then Q, if Q then P is called the converse. And here's an example. If we're given if it is raining, then it is cloudy, then the converse would be if it is cloudy, then it is raining. And the converse of a true statement can be true or false. For example, it is true that if it is raining, then it is cloudy, because rain comes from clouds. However, if it is cloudy then it is raining would be false, because we all know that it's possible to be overcast but not raining. So let's go ahead and determine the converse of these true statements, and then determine if the converse is true or false. If a figure is a pentagon, so this would be P, then it is a polygon, would be Q. So we're going to reverse the order, and the converse would be, if a figure is a polygon, then it is a pentagon. And this would be false, because if we can sketch a figure that's a polygon and not a pentagon, we have our counterexample. So for example, a triangle is a polygon, but it's not a pentagon, and therefore it shows the converse is false. Our second example, if two lines never intersect, then they are parallel. So the converse would be, if two lines are parallel, then they will never intersect. And this converse is true. If two lines are parallel, by definition, they will never intersect. Let's finish by talking about if and only if statements. These are also called biconditional statements. If a statement is true and the converse is also true, we can state P if and only if Q, and we can express the same thing using either of these two notations. Remember, this means if P then Q is true, and if Q then P is also true. And here's an example. If two lines are perpendicular, then they form a right angle. This is an if and only if statement because the given statement, if P then Q, is true, and it's also true that if two lines form a right angle, then the lines are perpendicular. I think we'll go ahead and stop here for this video. I hope you found this helpful.